query point is belonging at the starting neighborhood, suppose you have to calculate the functional value at 70, means you have to calculate area A, or that is the functional value at x equals to 70, 75, 81, 82, 83, suppose 86, whatever. These type of values are lying at the starting neighborhood in this neighborhood. So you will use Newton forward interpolation. Okay, you will get better answer. And if the asking point is lying at the ending neighborhood, means at the neighborhood of 100, means you have to calculate A area at the point x equals to suppose 99, x equals to 98, okay, or 105, 102, 103, like that. These are the points are lying at the ending neighborhood. You will use Newton backward interpolation to get the better approximate value with less error. So only that is the logic. If the asking point is beginning neighborhood, you will use Newton forward interpolation. Asking point is ending neighborhood, you will use Newton backward interpolation. And if you will use that, is scientifically more correct. Okay. So now you may be able to construct the forward and backward interpolation polynomial, interpolated polynomial with the help of this formula. बोलो फॉर्मूला थोड़ा ध्यान से याद कर लो. What is backward interpolation? For backward interpolation, you have to pick up the lower diagonal elements. Lower diagonal elements means from last value, last difference. These values you have to consider. And for forward interpolation, you have to consider the upper diagonal elements. Okay. So now, if I'll ask you logically, suppose calculate area of circle with diameter, suppose 105. So for the second question, calculate the area of a circle or circle with diameter 105. Then you just tell me which constructed polynomial you will adopt or consider. Which constructed polynomial you will consider? Newton forward interpolation, interpolated polynomial, or backward interpolated polynomial?
Sir, forward.
No, that is wrong. You just see 105. 105 position is where? 105 position is looks like after 100. 105 in this place, that is after 100. So it is in the neighborhood of 100. And that is why I am again and again I'm telling you, if the asking point, query point is lying at the beginning neighborhood, in starting neighborhood, you will use Newton forward interpolation. If the asking point lying at the ending neighborhood, you will use backward interpolation. Then you will get less error, better approximate value. That is the scientific logic. Okay. Is it clear? So first to calculate that, suppose I am going to calculate this one. Obviously you may be able to construct forward and backward interpolation. After getting that backward interpolation, in that polynomial put 100, 0.5, 105, you will get corresponding a or y value. So our formula was for, suppose, backward interpolation. Tell me what it was. You just see again little overview of that formula, backward interpolation. Y actually function of x, that y is there in the question. Y is the actually area A, and x is the diameter D. Okay, so y equals to function of x, that is written as yn is the last value in the difference table, plus u grade yn. Grade yn is the last value of first difference column. Grade square yn is the last difference value of second difference value in the second difference column. In that way, all the bottom values of the differences columns you have to consider, means all lower diagonal elements you have to consider to construct this formula. So that T I have written here, yn, grade square yn, up to grade yn, all these are lower diagonal elements. And that will be rearranged, associate along with the coefficient terms. How it is increasing, you just see. In first term it is 1, here 1, second term u, third term u plus 1 by factorial 2, next term u plus 1, u plus 2 by factorial 3. In that way, last term this one. That coefficient terms along with the lower diagonal element associately multiply and add. That is the series sum calculation or formula, where u is nothing but transform variable here, x minus last value of x given by space length h. And it was in forward interpolation formula was there, that is we have done in program also in CS1 group. But for the backward interpolation, how it is changed little bit. In forward it was factors are all minus. Here all the factors are plus. U plus 1 by 2 factorial 2, u plus 1, u plus 2 by factorial 3. In that way your factors are increasing. Okay, let's see what it will happen. You are seeing the lower diagonal elements, that is suppose yn means y value at last y. Last x means last x is 100. So in that point y value is this, yn is this, that is grade yn, that is grade square yn, grade cube yn is here y4 actually. Basically this is x0, this is x1, this is x2, this is x3, and this is x4. X0 to x4 corresponding y values are y0 to y4, y1, y2, y3, y4. So basically this is your yn is nothing but y4, and grade yn is nothing but grade y4. Is it clear? Y4 is last value here, so n is 4 here. Okay, so tell me your polynomial y approximately, y actually y is here. What is y? Y is here area approximately. Y is a function of x by the backward interpolation polynomial. Last value yn means this 7854 plus u into grade yn, u into grade yn 766 Then u plus 1 by factorial 2 means 2. Great square y1 means 40. This one. Then next term is follow u plus 1 u plus 2 by factorial 3. Factorial 3 is 6 into great square y1 is 2 means this one, and last value is 4. So that is will be u plus 1 u plus 2 u plus 3 by factorial 4. What is the factorial 4 value? Factorial 4. Factorial 3 6. Factorial 4. That is factorial 4 into last value 4. And what is u? Where u equals to x minus x0, x minus xn by h. Actually x is nothing but asking point means 100 point, xn means last value of x means 100, and h is the space length in between the x argument 85 minus 80 or 100 minus 95, whatever it is 5. So that is nothing but 5 by 5 means 1. So what is u? U is 1 here. In this expression you have to put u1. So what will be this? U plus 1, u plus 2, everything you may be able to calculate 1, 2, 3 by 6 like that. So your calculation will be so easy. You put that u1 and calculate a. My logic is you are getting the point. Are you understanding? Why I have not used here back forward interpolation? That logic also you should clear. If my asking point was, suppose I have to calculate, suppose at 81 area. This is the diameter. I have to calculate area at diameter 81. The 81 is belonging at the starting neighborhood, at the neighborhood of 80. So I will use Newton forward interpolation. But asking point is 105. That is why I am using here Newton backward interpolation. Only that is the logic.
Sir, if asking point will be 89, then
asking point is 89, then actually you do have step by step another techniques also in between. Suppose exactly in 50%, if it is 89, then also you will use here in your syllabus forward interpolation. But if it is exactly in between points, then there is some other technique, that is Stirling and Bessel interpolation techniques. That is, I will tell you at the later. Okay.
okay, sir.
Okay. If it is in between point means near about 50% means middle point, then you will use Stirling or Bessel's interpolation techniques. But that is, I think you don't have in your syllabus also. I will check. Okay. But whatever from the starting point, which will be the nearer? It is nearer to starting point or it is nearer to the ending point. Then on that basis, you will choose your techniques. If it is nearer to starting point, you will use forward interpolation. Nearer to ending point, you will use backward interpolation. Okay.
Okay, sir.
For 89 also, you will use Newton forward interpolation. That will be scientifically or logically correct. Because 89 position is, this is nearby 80, more near than 100. More nearby 100. So obviously you will use Up to now, whatever the logic you are understanding, on that basis you will use forward interpolation. So tell me, u is 1, so simply calculation is there. 7854. What is the area? U means 1 means 766. U1 means 1 into 2, 112 means 2 by 2 means 40. This is U is 1 means 1, 2, 3. 6 by 6 means then 2 plus. This is U 1, 2, 3, 4 means 24 by 24 means cancel, only 4 is there. So what is this value?
8666, sir.
8666. Okay. So you just see 8666. At 100 it was step by step, actually on the basis diameter increase means area increase. At 80 diameter was looks like this. At 85 diameter looks like this. 100 it was looks like this. 7854. So 105 approximately it will be looks like on the basis of this formula 866. 866. Okay. So for backward also you may, in which way we have calculated this series sum in terms of computer, means with the help of computer, that series sum. Within a loop, sum equals to sum plus term. In the term, how it is increasing, that associate coefficients I assign by a product value p equals to 1, and within a loop p equals to p into something such that that associate coefficients will be increasing. That product term you just multiply along with the lower diagonal elements, and within the program you have to construct the difference table, and you have to pick up now for this technique lower diagonal elements and associate factors. You just multiply and do the series sum. So when we will write the program with the help of, for any data sets, generalized program will be there. For any data sets, we may be able to use this technique. If the asking point is ending neighborhood, so obviously we can able to interpolate or create some other points or value for the given set of discrete data points. Till now, any query?
No, sir.
I told you in last class, actually in the operators there is a interrelationship. So forward, backward, shift, central difference, divided difference, all the operators having the relationship and small question can be built. And I think you have to open the book and you have to see in the interpolation techniques introductory chapter, that is at starting you will get all that relationship, and everything is very interesting problems you will get, and all that problems you just try to note it down. Actually that type of things I am not doing in class, but for the short question or competition purpose question, everything you will get. So for time being, little bit, suppose can we able to establish little relation along with the backward difference operator? So forward difference operator and shift operator, suppose you know del of fx equals to f of x plus h minus f of x, isn't it? And last class I told you one relationship del n y r equals to grade n y n plus r. That is also important relationship between the forward and backward difference operator. That is, if I write e of fx minus 1 into fx means that is e minus 1 this operator into fx. So simply function I am cancelling both sides, so operator relationship will be del will be shift minus 1. Similarly, backward difference operator can be able to establish relationship. Grade fx f of x minus h. That is, I can able to write fx minus e inverse. Shift operator is working as inverse also. Fx. So that is 1 minus e inverse fx. So along with the backward difference operator, your relationship is now becoming looks like that 1 minus e inverse. Are you getting? So this difference operator is actually looks like in limiting case working like a derivative operator. Working like a derivative operator. So can you able to establish what is the relationship between the derivative operator? Suppose derivative operator I am writing ddx, that is equal to capital D, and del derivative operator and del operator, what is the relationship is there? And that type of relationship, every relationship you have to just pick up, and you should be aware and well known about these operators. Pick up from the book, nicely note it down. So only these things I am doing here, and remaining things your assignment. Okay, that is I am telling you. Suppose f of x plus a. In Taylor series expansion, what it will be? F of x plus h, f of x plus h square by factorial 2 f double dot x, isn't it? H cube by factorial 3 f triple d. That is Taylor series expansion. Bolo. This expression you know, I think. Taylor series expansion. If I will bring back, this is left hand side, f of x plus h minus fx. What would will be in the remaining right hand side? Okay, so for the time being, you just actually that is the del of fx, f of x plus h minus fx, that is del of fx. So actually that is I am not doing for the time being. What I am doing actually that fx plus h fx plus h square by factorial 2 is actually this is f dot x. So actually f dot x means, tell me, del f by del x, and that is I am able to write d of fx. Similarly, f double dot x will be d square fx. Triple dash x is dq fx, because d is the derivative operator. That operator will working on fx. D square operating on fx means it is second derivative. dq operating on fx means it is third derivative of fx. Okay, so this is dfx is dfx h square by factorial 2 d square fx HQ dq by factorial 3 fx. In that way, your terms are increasing. Is it clear? So try to write this is 1 plus hd plus hd square by factorial 2 hd cube by factorial 3. This way outside fx, and e of f of x plus h is the e of fx. Shift operator on fx, that is f of x plus h. So fx you just cancel both sides. Fx cancel both sides, and what is this expression? Inside expression, if I will write in compact form, this is e to the power hd. Okay, so you cancel both sides fx, so your shift operator is becoming e to the power hd.
हाँ हाँ
बोलो.
नहीं की क्लास है.
So up to this much, a small relationship you are getting here. So E you may able to write in terms of forward operator. So what will be the E? E is actually 1 plus del. So if you will write E is 1 plus del e to the power hd. This is one relationship. You may be able to express if the you have to given some statement, you have to prove something. Suppose derivative equals to something, then you just take logarithm in both sides. So you to the hd is equal to log of 1 plus forward difference operator. Sometimes you just divide by h. Then this is 1 by h, and that is actually dy by dx. So along with the derivative operator, it is equals along with the forward difference operator 1 by h log of 1 plus del. But it is still linear relationship. Expression is linear, so linear relationship. So actually d is proportional to derivative. Looks like that. Okay. So like derivative operator is working on the function. Suppose a polynomial, a first degree polynomial. I am writing here a polynomial is, for example, y equals to 2x plus 3. What is the first derivative of this? What is dy? First derivative dy by dx. 2. Second derivative 0. You just try to calculate difference operator also becoming first difference constant, second difference 0. So if I will calculate del y, it will be yx plus a. So del y is the basically function of x. Y is the function of x. So basically yx plus h minus y of x. So basically this is 2x plus h plus 3 from this function actually minus 2x plus 3. So that is 2x plus 2h plus 3. So basically 2x cancel. So 3 cancel. So simply it is becoming 2h. 2h. H is this on the basis of given discrete set of data point. H is the constant value. Step length is constant. So that is the constant value. You just try to first difference. Try to calculate second difference. Del 2y by del x. So what it will be? Difference of first difference. So del of y x plus h minus del of yx. So whatever first difference is constant value. So del of y x plus h, whatever it is h minus 2h. So this is 0. So suppose you do have lots of data points. Suppose x equals to logic, and that is yx. You do have lots of data points. Suppose you do have 5 data points or 10 data points, whatever, and data points, lots of data points. First difference del y, first difference you are getting constant, and second difference you are getting 0. Second difference you are getting 0 everywhere. So with the help of suppose 5 points, as for example I am asking you 5 points. So with the help of 5 points, you may be able to approximate a polynomial of maximum which degree. Maximum which degree polynomial you may be able to approximate with the help of 5 points. That logic I told you. देखो
5
एक
degree, sir.
जैसे 2 पॉइंट लेके एक पोलिनोमियल बना सकते हैं, 3 पॉइंट नॉन लीनियर पोजीशन है, तो विद द हेल्प ऑफ 3 पॉइंट्स वी कैन एबल टू अप्रोक्सीमेट सेकंड डिग्री पोलिनोमियल. Okay, with the help of 4 points we can able to approximate maximum third degree polynomial, but all the points are in non-linear position. That is why maximum that much degree you may able to approximate. Now points are suppose lying in the linear position. Suppose I told you points are lying in the linear, this point, this point, this point, and this, all points are lying on the straight line. Suppose, so I may consider these 4 points, this one, this one, this one, this one. So after considering these 4 point or 5 points, if I will calculate the difference table, first difference I will get constant value always. This is the constant, 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 constant. And second difference, k minus k 0, k minus k 0. Okay. So that time if I will going to construct the interpolated polynomials, you just see. Second difference is 0. So after that term is 0 here. After that term here is also 0. Simply I can able to use only up to these 2 terms. So it will produce a straight line only or nothing else. It will produce a straight line only or nothing else if the points are linear position. So in the calculation or from the difference table you may decide exactly which degrees of polynomial we are going to have for these data sets. After constructing the difference table, you may decide, because it is looks like operator, looks like derivative operator. So derivative operator में जैसे polynomial nth degree polynomial को nth difference करेंगे तो constant होगा, n plus 1th difference 0 होगा. As like as derivative. जैसे फर्स्ट डिग्री पोलिनोमियल फर्स्ट डिफरेंस कांस्टेंट, सेकंड डिफरेंस एंड हार्ड डिफरेंस इज 0. डेरिवेटिव सिमिलरली डिफरेंस इज आल्सो, and that is why this relationship having the linear relations and exact relationship, if it is asked to you, right, establish the exact relationship, that is this relationship. Okay. अब देखो हम बोल रहे हैं 10 पॉइंट्स है, 10 points. So with the help of 10 points, I know the logic we can able to approximate maximum 9th degree polynomial. But what I am getting actually, I am getting third difference constant. Third difference constant. All value are same in third difference. This is the constant, constant, constant. Means constant, means fourth difference and remaining difference is 0, k minus k, k minus k. So with the help of 10 points, third difference constant means with the help of 10 points exactly which degrees of polynomial we are going to get. बोलो, third difference constant means third degree polynomial. बट मैक्सिमम अगर 10 पॉइंट अगर नॉन लीनियर पोजीशन में रहेगा तुम्हारा, तो then to join these all points you will get a non-linear curve, then it will be maximum 9th degree polynomial. But After constructing the difference table, I am seeing third difference constant. So it will give you exactly third degree polynomial, not the maximum case. Logic is clear. Follow, Babu? So in
Yes.
step by step, this type of relationship, or try to understand everything so logically or scientifically or little deeply, so that why these are the things you are studying these things. It will have some importance. That importance you just try to explore. Okay.
Yes.
Okay. Today your class is over. Or any query? We are ending the meeting.
No, sir.
Nothing, sir.
Thank you, sir.
You are welcome.